right. Good afternoon. I'm Brigitte, the Vet CEO of Materialise, and I'll share this presentation together with Egwin, who at Materialise is the person that takes care of all of our product portfolio that is dedicated to the preprint steps with, for example, our flagship product, Magics, Streamline, and others. But by way of introduction, so what we're going to discuss in this talk is we see today a lot of applications of additive manufacturing brought to the market, but a lot of companies are actually struggling to scale the applications, partly also because it's hard to do this cost effectively and efficiently. Now, what we'll talk about in this presentation is this pressing need for bringing the cost down, which can be achieved by making the whole additive flow from design to print a lot simpler, taking a lot of the complexity out, automation, and we've heard a lot of these themes already throughout the day. But we'll also talk about the pressing need for the industry to collaborate in different ways together in order to attack the challenge that we are all facing today. And I hope that by the end of the presentation that you've all gotten a feeling for how you can enhance your additive, if you are in the additive field, your additive capabilities, and how we can look at these challenges in a slightly different way. Now, if we look at the future of manufacturing, if I can get the slides to work and see. No, not yet. I'll just do it like that, so it should work. So if we look at the future of manufacturing, which we truly believe in, today we are convinced that there shouldn't be a trade-off between volumes and flexibility or scale and flexibility, which is what we're seeing today. What we believe in is that there should be a straight path from some of your innovative designs to transformational products, and that goes a lot faster and easier. We do believe that digital manufacturing can actually power some of the industries like aerospace and medical, which are complex and regulated industries, by the unprecedented levels of precision and personalization that additive can offer. We believe in new levels of, or enhanced levels of automation, which make the whole thing easier, more flexible, and which brings us these agile supply chains that we all need, and that reduced cost that we need to scale. And we believe in the ability to fine-tune your applications to certain industries, or even individuals, to create completely new possibilities, which in some sectors and segments we already see, the medical one being one of them, but not in all, a whole lot of other sectors. So that's what we believe in, and we can see that future. But if we look at the reality today, that's not where we are yet. That's not what companies feel today, that those are the possibilities that additive gives. We've done a recent survey, and in that survey, we learned a couple of things. One is that for companies today, they don't need to be convinced about the power of additive or the possibilities of additive anymore. But what we need in this industry is more guidance as to how to scale effectively, cost efficiently as well. What we see and learned from that survey is that companies today are struggling with a number of things. One is the perceived complexity. It's hard to do additive end-to-end in a good way. And you need skilled labor to do that. And we don't have a lot of the skilled labor and workforce available. So that's an issue. We also learned that companies are struggling with their costs that I talked about. It's just too expensive for many of the applications, even though there are ways to bring down that cost. And again, we'll give you some examples as to how to do that. But they also struggle with the integration of additive in a broader ecosystem, because additive is not an island. It needs to integrate in the other, in the whole ecosystem, the manufacturing ecosystem, and it obviously needs to comply with the regulatory requirements in some of the sectors that we talk about. And that's the hard thing today. Now, obviously, a lot of the companies in this room, a lot of the companies in additive can play a role here. Certainly, software plays a big role here. And of course, as Materialise, we believe that with our CO-AM platform, that we have ways to address that challenge. Obviously, with an end-to-end software, which is what GoEM is, our platform, you can find more efficient ways of generating, of driving your process. Obviously, with that software, you can connect the dots, collect the data that you need to eventually use machine learning or AI programs on it. You can do plenty of stuff. But what I fundamentally believe is that it's not just one company that can solve that challenge. We need to solve that challenge as an industry and collaborate better and more than what we've done so far. Just have a look at what it means for this industry. We are faced with a myriad of interfaces, platforms, operating systems, and our customers are struggling with the fact that they need to connect software, different pieces of software together to get to a seamless workflow. They're struggling with the fact that to that software, in order to collect the data throughout the system, you need to connect a multitude of these devices, printers, post-processing equipment, et cetera, et cetera. So it's not just one company that can solve that. And everybody is trying to solve it, but essentially all that time and resource is going into solving a basic issue rather than bringing real innovation to the market. So we need to change our approach. And that's what I call the collaboration catalyst. Let me talk about that a little more. So as an industry, in the additive industry, we're a little stuck. So let's have a look at how other industries have, what they've done, when they were a little stuck and didn't quite see the growth that they wanted to see. I want to look at the automotive industry, and in particular, electrical vehicles. Elon Musk, Tesla, obviously being a leader in that industry. Years ago, when the electrical vehicles came up, Elon had this dream of really transforming the industry, transforming mobility, and driving sustainability with that. But he also realized that if he was going to, with the multitude of patents that he had built, and the company had built, if he was going to block the way for many others to come in and bring other electrical vehicles to the market, that wasn't in the best interest, nor of Tesla, nor of the whole community. So what he did is that he decided to make all his IP publicly available and free for everybody to use. Now, let's have a look at the facts. When he decided to do that, there was only less than 1% of the vehicles worldwide were electrical vehicles. Look where we are today. Electrical vehicles, I think it's hard to think them away. So there's companies like Audi that want to become by 2035, I believe it is, an electrical vehicle only company. BMW sale, 15% of their sales today is in electrical vehicles. So the industry has massively grown. And guess what? Tesla is still the number one. So it has benefited them while benefiting the industry. It can be a win-win. And that's exactly what we want to do. We want to make a win-win out of the fact that we open up, we collaborate, we share to the benefit of the industry, and every single company can grow in that environment. Now, that's easy to say that. Let's give you a couple of examples of what we are doing as Materialise, and hopefully that's going to inspire many of you in the industry as to how we can collaborate and change the game in that way, building partnerships with other companies, but also opening up our ecosystem and the algorithm base that we've built over the last 34 years for others to use to accelerate the industry and drive growth and make it easier and faster and cheaper for customers to scale additive and get to that potential that I described. I'll hand over to Egwin to lead us through the rest of the story. Egwin, the floor is yours.
So to highlight a little bit the whole partnership and the ecosystem of GoEM, you see there are a lot of partners that we have. I want to highlight two of them. Two is Siemens and Antop. Now, what I've heard from all of you as well is meshing has its challenges. I've heard everybody here facing the challenges of the complexity of the designs and also pushing them to the printability of the machines. So a few years ago, we said, okay, we're going to open up our Magics ecosystem as well, and we're going to add other kernels or allow other kernels to be part of the Magics ecosystem. So we started with Siemens. We added the Parasolid kernel into Magics as well. Just a question, how many people know Magics or are using Magics? I see, okay, awesome, that's good to see. So we added the Parasolid kernel, so now you can definitely keep working on your BREP level, so you can push your CAD files, your BREP files also into the data and build preparation for additive manufacturing. But as Bradley yesterday also showed from NTOP, what we have done now is also added the implicit kernel from NTOP. So basically what we do, because making all these crazy designs is awesome, but getting them printed is a totally different thing. So what we have done is basically integrated the NTOP kernel in Magics natively. So if you have your crazy designs that you want to print, the heat exchangers, for example, I have noticed that heat exchangers are really hot right now, so that's awesome to see. So we can now push them without any conversion to a mesh or whatever up until the print. So data prep, build prep, but also slicing and so on is now done natively on a implicit level. So that means that you have significant speed increases and performance increases. So this was not printable at all, was not sliceable at all with current technology. And what now happens is that you can slice these complex platforms. So this is just a miniature version. The real part is 60 centimeters by 60 centimeters by 45. You can print 4 of them on the SLM 600 machine, and slicing takes only a matter of hours, like 3 to 4 hours. So that's a game change from unsliceable to in 4 hours. So this is one thing, but this is only on Magics level. So the Magics is the user interface. What we're now going to do to push this to the next level, because we can't keep adding kernels to our Magics system ecosystem, we are opening up our secret sauce. Magics has also always been perceived as being protective to its algorithms, but as Brigitte also said, to push really the collaboration in the industry, we have decided that we're going to open up the Magics SDKs and the Materialise SDKs available for the full end-to-end production flow. So that means all the algorithms that we have, and we really love our algorithms. We have over 800 on Trimatic, on Magics, on the build processes, and so on. We will open them up via SDKs that you can use in your own workflow. So I'm going to give you some examples of what we have done behind closed doors, because this is not a product yet, so we're going to push this to the market soon. We have been validating this with mass customization workflows, with automation in data and build prep, as you have seen in Magics itself, but also created a visualization tool, because it's really important that we still create a full end-to-end solution to make sure that you have all the tools available at your disposal. So how does it work? So at first we started to change the core of our algorithms. So our algorithms are written in C++. C++ is not really scalable to everybody, so we have changed those algorithms and we push them to a Python algorithm. So that's one thing. We changed the user interface from Magics all the way to a nodeflow editor. I have seen from all the presentations here today and yesterday that everybody loves a nodeflow editor, so here we are. It's also available there. But documentation, and this is also something that we have seen during the presentation today, it was from Metafold, from Daniel. Making your SDKs available is only one thing. Documentation is key, making sure that people can use your SDKs, that they're all documented. And we have a full library. Every algorithm is documented on how to use, how to implement, and so on. So this will be made available really soon. And I want to give you an example on really the power of having a full end-to-end workflow based on the Magics SDKs. So I was thinking, okay, what kind of application can we use? First I thought it was like, okay, heat exchangers. We have to do heat exchangers, it's really powerful, but I'm lucky that I didn't choose it. I'm happy that I didn't choose heat exchangers. I went for eyewear. So what you see here is basically a flow on eyewear. So what you can do, and it's a little bit stuttery apparently, the video, but I can guarantee you it's smooth. Basically you can go to a boutique, get a scan of your face, and all the designs of the classes are part of an inventory. But not one face is the same, we can, thank God. But what you can do here is you can add your designs that you want, and those designs will be automatically adapted to the shape of your face. You will get a recommendation out of this. You can change your styles as well, and then you can start swiping. I want to have those glasses. I want to override it if you want to, but not suggested, of course. And afterwards, you get a full customized glass eye frame based on the shape of your face. And you get a very nice 3D scan of your face out of it. Not as nice as the rig that we saw yesterday, but it's still pretty good. When you press buy, you trigger a fully automated, and I heard Ben, there's no 100% automation. You can always override this, as you see here. You trigger a order, a launch to order based on the Magics SDKs. So what you see here is that you can still do small design changes. So you have to take into account that this is based on the geometry of your face that you just scanned. So the design of your frame will be automatically adapted to your scan. And there will be made some adjustments. So for example, the pentascopic angle to make sure that your lenses are reflected well to your eyes are changed based on the scan data that we have. And you can always override this as well. Now afterwards, if it's based on metal eyewear, you can start doing your build prep. So one thing that we know is with support generation, for example, if you add supports and you have to do minor design changes, the difficulty is that you lose your supports. There's nothing as annoying as losing your supports after you're done and you have to start over. So what you can do also with these algorithms is basically create a support strategy and then have a full preservation of your supports based on the data that you get in. So every time that you get an eyewear a frame in, it will be automatically changed and adapted according to the changes that need to be done. Now, most frames are being built in nylon, so that means that you can also nest them. And as we also saw, that nesting is really difficult to do, but especially for those polymer iframes, the quality is extremely important. So what you can do, and this is really unique and this is really powerful that we will enable for you as well, is that you can make your changes based on slice level as well. So you can have a full associativity within the workflow that you can add your blocks, you can create your slices, you can do your hatches, and out of that you can still make changes that are being fed back into the nested build as well. So you can make changes on slice level, on hatch level, and it's going to be fed back into the workflow. So that's very unique. So this is also the main reason why we have created our own node flow editor, because we have to be able to visualize this, to render this as well. But if you're using Grasshopper or Rhino or whatever kind of automated workflow, you can also integrate these SDKs as well. This is really powerful, and this is something that we will enable as well. But why are we doing this? Again, the openness, we really want to share our SDKs as well to really push this to the end. And this is really unique because at this moment in time, you can actually have one workflow from design to really a printed part that is fully traceable, full associativity as well in the workflow, and that you can always have a check within the workflow itself. So why are we doing this? Again, optimizing and reducing cost. Manual and repetitive tasks take a lot of work, take a lot of time with highly educated people. We want to scale the production with automation. Automation really is key for scaling, but we also want to decrease the time to market for AM applications. So this is really our way to plan and manage and optimize every step in the 3D workflow. So yeah, if you're interested, let me know. We can really, if you're already a Magics user, you can already start talking on leveraging this. If you're not a Magics user and you really want to integrate these SDKs in your workflow, we can definitely explore what is possible there as well. So this is our way on actually sharing and opening up our ecosystem. So all our 800 algorithms will be made available via an SDK. And you can actually have a additive manufacturing block into your own workflow as well. So that's it for the presentation. Thank you so much for the time.